Here's a question that's geometry. It says, state whether a triangle with the sides of the given lengths is acute, right, or obtuse. Well, here's the formulas to use. It's all based on the Pythagorean theorem. If a squared plus b squared, the sum of the squares of the two shorter sides, c is always the longest side, is equal to c squared, that's a right triangle. If a squared plus b squared is greater than c squared, c again is the longest side, that's an acute triangle. And if a squared plus b squared is less than c squared, it's an obtuse triangle. So let's try 7, 8, 10. 7 squared plus 8 squared. And I want to compare that to 10 squared. 7 squared is 49. 8 squared is 64. 49 plus 64 is 113. And this is 100. 113 is greater than 100. Greater than, that's an acute triangle. Next one. 2 squared is 4. 6 squared is 36. 4 plus 36 is 40. 9 squared is 81. 40 is less than 81. It's less than the long side squared. That is obtuse, Uncle Tanus. You can look that up. All right, 3n, 4n, 5n. 3n, the whole thing squared, plus 4n, the whole thing squared. And then I have to do 5n, the whole thing squared. Well, 3 squared is 9, n squared is n squared, plus 4 squared is 16, n squared is n squared, and then 5 squared is 25, n squared. 16 plus 9 is 25, n squared equals 25n squared. Since they're equal, that's a right triangle. And then this one, 4, 6, 2 squared of 13. Well, 3 times 3 is 9, and 4 times 4 is 16, so this is square root of 13 is bigger than 3, so this is bigger than 6. That's the long side. 4 squared is 16. 6 squared is 36, and I'm comparing it to 2 square root of 13 squared. 2 squared is 4. Square root of 13 squared is 13. 4 times 13 is 52. 16 plus 36 is 52. Those are equal. That is a right triangle. Questions 23 through 28, use your knowledge of special right triangles. Well, here's a right triangle that is a 45. If it has one 45-degree angle, it has to have two 45-degree angles. And to be a special right triangle, this is side, 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 square root of 2. Sometimes they just write 1, 1, and then square root of 2. But anyway, the side opposite, if this angle is 45, so is this one. This is 45. Side opposite 45 is 3, so x is 3. And the side opposite 90 is the side square root of 2, or 3 square root of 2. Next one. Hold on, let me make a little bit more room here. I just need scrolling room. Okay, the next one. This is a 30, 60, 90 triangle. And in a 30, 60, 90, side opposite 30, if I call that S, side opposite 90 is 2 times S, and the side opposite 60 is S square root of 3. So here, it's given me the side opposite 30 is 5, so the side opposite 90, which is X, is 2 times 5, or 10. I'm going to put commas here. And that should be a 10, not a 16. It almost looks like a 16. And then the side opposite y, or y is the side opposite the 60-degree angle, is S square root of 3, or 5 square root of 3. Next one. This also is a 30, 60, 90. And let's see. Side opposite 90 is 50, so that's 2s. Side opposite 30 is s, or 50 divided by 2, which is 25. That's x. And the side opposite 60 is going to be s, 25, times square root of 3. So that answers all the questions there for acute, obtuse, right angles given side lengths, potential side lengths, and special right triangles.